For this tutorial, I am just going to be giving you some general guidance of how to go through completing question 3 of task 3. The previous tutorial has already gone through question 1 and 2, and it gave you guidance for the start of doing the doubly linked list class. But here I'm going to go through it. I'm not going to really do any coding here. This is up to you to spend some time to make sure that you properly understand linked lists yourself. And I just want to give you guidance on how you can go through completing each of these questions. And so each of the methods that we have here, I'm just going to give you some general guidance, maybe tiny bits of coding, but more just guidance on what you should be doing for each of the methods. So for the first one is you have to do the get size method. Right now it's just returning -1 just so it compiles, but this should be returning back the number of nodes that are in the list. Now, one quick way that you could do this is you could just set up a moving reference that goes from the beginning of the list to the end, counting how many nodes there are. But this is really inefficient if you think on the asymptotic complexity of the method. That as the list gets longer, every time you call size, this will also take longer to actually run. Right here. So a faster way is to take advantage of that, hey, you're in a class. So why don't we just set up different rules that we just keep a count of the actual size, and so anytime we do an add or remove, we properly update that count. So what I'd suggest here is just start by creating a size variable that you expect to have in the list. In your constructor, set your size equal to 0. Size, not souls. But your size variable should always hold the current count of how many nodes there are in your list. So in the constructor, when it's empty, it's got 0 or fine. And here for your size, then we can just return back size. But what we have to remember now is in any method where we're adding, we need to increment the size if it's properly added. And any method where we're decrementing, we need to, by removing a node, we need to properly decrement the size to remove a value. So the iterators you leave, and we've got the add to front. So first thing we need to do in here, so I'm just removing this. You got to do your comments is this method will create a new node that contains the data and add it to the front of the actual list. No matter what, we know in the case we have if it's empty or not empty, we need to add it differently, but we need to actually increment the size. So no matter what, when you come in here, you're going to be incrementing the actual size. Otherwise, need to check for empty. Because if it's empty, there's one case of how you handle it. So the first thing you should do is check to see if the actual list is empty itself. And then 2, if not empty, you have some different work. So if it's empty, you need to work, okay, well then start and end just equal the new node. That's what you expect. So the start and end references. So if it's empty, right here, you just make that the start and references both equal to the new node that you're adding to the list. If the list isn't empty, then you need to go through doing the similar steps of updating everything. So setting the actual temporary reference equal to the add to the front, or so your new node, its next has to equal to what you start is. Your start's previous has to equal your new node. And then you need to move your start back. So this was covered in the previous one. Okay. Now when we do the end one right here, then it's going to be a similar thing to the actual start, so the add to end. So if it's empty, start and end equal that node, we're still incrementing. Otherwise, if not the end, then you need to deal with this one differently. Is now you're not working with the start reference. You think, okay, well, I have the end, and I have my new node. The new node's supposed to be the new end, so it's your end.set next is your new node. And then your new node dot set previous is your end, and then your end move forwards to what your new node is. So and just making sure you have the size. So I'm putting the size down here at the bottom because no matter what, if it's empty or if it's not empty, we will be adding. So that's why I'm incrementing the size. And Then right here, same thing for the add to front. Now add sorted is more complex. So once again here, no matter what, if the list is empty or not empty, we are going to be actually incrementing the size. So we need to add that in. The add sorted is different here because you first have to find the right location to add it in, and then you need to detect, okay, well, where in the list am I? In the beginning, the end, or the start? But to begin with, is the list empty? That's your first one. So first step, just check, is the list actually empty? So is that the empty case? And if it's empty, well then it's the same thing you expect before. Start and end equal the new node. Otherwise, if it's not empty, you need to go on to deal with the next cases. So first is you need to find the location to add. So 2.1. So you're going to need to setting up a moving actual reference that starts at the beginning of the list, and it's going to keep moving forwards until either we hit the end of the actual list or we actually have found the spot to add. So you have to remember you're checking that .next. If it's not null, we want to go all the way to the very last node and see if where are we in the actual list and find it, because we could be adding something that's sorted that is larger than everything that's in the list, so it's got to be added to the actual end. So again, you want to set up a moving reference that starts at the beginning of the list and will keep moving through the entire list while it's not at the end, and right here that they can so while you're not at the end and that we haven't found the spot to compare to. Now remember here is compared to question 1 and 2, where we saw especially question 2 to compare, we need to use the comparator, but this time not just for equalities, is we need to keep moving forwards while it's less than, because we're doing an insertion sort, that basically we keep moving forwards until we find the right spot to actually where it's like, okay, the thing I'm doing is bigger than this element, so move to the next. It's bigger than this element, move to the next. It's bigger than this element, so move to the actual next. So that is the finding the add location that goes from right here. Now to remember from that is with your comparator. So comparator, I'll even show it here, comparator dot, you have the actual compare method that's in here that's expecting two things. Node to add, node we are comparing. So I'm not doing this as actual code, this is just a comment to tell you from there, is that when you're working with a comparator, you have the compare method that you'll call from it, and you want to give it the node that you want to add, and you want to give it the node that you're comparing to. And what we want to keep doing is that we want to keep moving forwards while this is larger than or equal to this right here. Doesn't even matter, maybe if they're equals, let's just say that it's larger than from right there. So what you have to remember is that it returns -1, and so I'm going to call this A, I'm going to call this B. So it returns -1 if A is less than B. Boom, boom. Returns 0 if A is equal to B. And returns 1, so a positive number. So you just say like negative number if it's less than, 0 if it's equal, positive number if A is greater than B. So you can start using that. You can start using that in your loop to checking. So you know, okay, well, I want to set up my moving reference equal to start, and I want to at least keep moving reference while it's not null. So we move to the actual end of the list. And we want to keep comparing and finding the first node that's larger than this one. So we could hit the very end of the list and it's null, then we need to deal with that case. We next need to then deal with, okay, returning back, okay, so moving forward and seeing if it's smaller. So we want to find the location that we're actually getting to. Once we found that location, we have to realize we have to actually remove, like, we have to do the insertion to the node before, so in between the previous node and the current one that we found, because you'll keep moving forwards the comparator until, like, let's say you're still within the list, you found it, and it's going to find the case where, like, okay, no, A is then find less than B. We'll keep moving forwards while we're getting a positive number coming back, and as soon as we don't get that, we'll stop. So if it's 0 or negative, we'll just stop. And what it means is we would have stopped at the current node that's larger. And so we've got to insert one step before this. So if you remember from the linked list video before, is that there's a trick where you can use a trailing object reference or reference that basically before you move your moving reference, you save the old one into it. And we're going to need that here, that we're going to need the beginning one and the ending point to do that. And now once we found those parts, is after we found that actual location, so everything from there, so 2.2, then you have to check, well, what is this? So, like, at the start, because what if the current reference you're looking at is at the start? Then you need to do something different. And so you know this means the moving node is equal to the start. Then you have to do one thing. And so basically you're doing an add to the front. Are we at the end? Right here. So in this case, is your moving reference equal to your end reference? Well, then you need to do an add to the actual end. Then otherwise, 2.4, adding in the middle. And so now we need to then do the proper manipulation of the next and previous references with the new node that's in there. Now be aware, in the video here, I'm only like talking about this and giving some points. In the actual tutorial in person, I'll be drawing stuff out on board. But for yourself, this should be your time not just to sit and look straight at the code, is to draw out some examples using, say, numbers, using like 1, 2, 3, 4, like use some integers, and draw out each scenario, and then think about the moving reference and redraw the steps before you go to the direct code. Okay, now we've got the get coming out of this next. So this one isn't too bad. This is the very beginning. So one thing is we have to throw an exception if the index is out of bounds for the actual list. And out of bounds means it's like it's a wrong value. So it has to be greater than 0 or less than the size. So index must be greater than or equal to 0. And it must also be less than your size. And you have size here. It can't be equal to it because we're always going 0 upwards, starting index 0. So it's got to be less than. So you got to check if that's correct there. If out of bounds, throw exception. An example of how to do this has been shown in the previous linked list video. Right here. Otherwise, if we've got the right one here, we think the idea is this is just a moving reference that has to go forwards a certain number of steps. If we know that we are within bounds, well, then we don't have to worry about how we move. We just have to go forwards a certain number of steps. And so this is where you should be setting up, again, a moving reference that goes to start and a for loop that goes from 0 less than and like goes up to the index you want. So keep moving and making sure that you're not going 1 too far or 1 off. If you're starting from right here, so you want to go from starting and go up to less than the index, not less than or equal to the index. And you just want to move your moving reference forwards, and then you get the data out and you return that. So 1. So set up the moving reference, forward, and proper for loop. So it's using a for loop, and then once you've got that done outside of the loop, then get data outside of the actual mover. Okay, it's not too bad of a one, as long as you practice with this. Now, remove at is a little bit more difficult to deal with. It's one of the larger ones to deal with. So first off, you have to deal with proper, that you can index, is that if it's within bounds right now, so throw an exception. If out of bounds, throw an exception, or if list is empty. That's the requirements right here. If index is out of bounds or list is empty, throw an exception. Otherwise, we know that we have the right point. Now here is we just have to go and get the actual node and start doing the removing from right here. But this is where, well, maybe we could start modifying what you actually had as the actual get method, that this returned the type that you had from right here. Well, what if we had something that just got us our current right node, and then we could start setting stuff up? So my suggestion is, similar to the linked list video, is you could make a helper method from right here that returns back the node itself. Right, this. So you can do the actual get index right here and returns back. And so most of this method would be just what you've seen in here. So you would have had getting right here, moving the moving reference forwards, and then using the proper loop to move it forwards, and then finally 3 return node. So then what you can end up doing there instead is in your get method after here for step 1 and 2, you could instead just call your get node method. So these are comments. Remember, you got to get the right code. This is not right code. I'm just commenting. This will give you an idea. So you get the rightness, get the data out of then your spot. And then you want to return that back. And so what that makes that nice here is, here, I just don't want this complaining to me about anything that's right up here. Oh yeah, and this is D node that we have. Sure everything compiles, not missing anything here. So just make a method called getNode. We call our getNode up here. It's returning the object here. Then the nice thing is, well, we can just reuse that down here. So step 1 is just get the actual node. So find the actual spot itself. And here we don't even then we need to worry about inbounds, as the getNode already does that for us. We just got the spot. And so that's step 1. Get the node, get the location we want. 2, we need to check the locations. Are we at the start? So this means we're doing a remove from the start, and we need to update references properly. If we're at the end, so it's the very last node, we need to update that properly. And are we in the middle? Now one key thing here is if we are in the middle, remember now too is we're doing a doubly linked list. So to get that trailing reference that I talked about earlier, there's even a faster way to do that is prev node is, well then that just equals your spot dot, make sure I'm calling the right thing here. Is that we need to have the previous node before us, so we can call the get previous. Then what's nice is that we then have the node. We can also get a reference to the node that's after our location. Right here, and then we can just start dealing with all the proper references. Is that if we're removing stuff, well then spot.setNext and spot.setPrevious should be null to unlink it from everything, and we can return the actual data. And then all we have to do after that is this then say, okay, previous node.setNext is next node, and next node.setPrevious is prev node. So nice way of using those nodes to get here. And so again, even come up here is this add. Boom. The add sorted is that are we at this end? Are we in the middle? Then right here, well then what will be really nice is that we know we can just get the previous node, and we know that between the spot that we found and this previous node is this is where we need to actually insert stuff. So that is your remove as long as you do it properly. So remember, if at the start, you're unlinking the nodes properly, moving the start forwards. If at the end, you're unlinking the nodes properly and moving the end back. Here, if you're in the middle, you can get the two nodes and then relink it from right here and reusing code. And then finally for the actual contains, remember this is just the same as just a moving reference from right now. So true or false. So right now you need to then first start by just taking out this node right here, and you're working with the comparator, and you just have to remember the rules that we had from earlier. So going back up to here, that you have the comparator and the other nodes you're looking for, is that you're just seeing if there's a match, if this is in here at all. So we know we have a comparator, and we're really just caring now about if this A, so it's going to return back, it's going to return back 0 if A equals to B. So when the compare that we're comparing to between the two. So we just need to set a moving reference to the very beginning. We need to go through every node, so while the mover reference isn't null, so let it fall off the end of the list. And if we find any case where it matches like this, then we just return true. Otherwise, we return false. So this is another simple, very small loop. So your contains method is a very small one. Your remove adds a little bit larger and more complex to it. And also remembering here, if you're doing this properly, your size minus minus and making sure you have this right location. I'm just putting it here. You guys need to put it in the right location depending upon what you're doing within here, but we need to decrement the size from right here. Your get node method is a smaller one that's a moving reference, but more of a for loop to stop at a certain location, so the get node. And then the get will use the get node from right here. Your add sorted is another big, larger, complex one, but it's really more is it empty, finding the right location, checking where you are to do some of the work, and moving forwards. And then your add to end and add to start. Okay, so I'm going to stop there. That gives you a basic reference. You should go through this. Even though I've not done the code, please don't go just search out other code online for this. It's not going to help you learn it yourself. You're going to have stuff on this about the midterm and the actual final where I'll switch it up to test, do you actually understand it or are you just memorizing it? And this is to help build your abstraction skills, which are very important, and to also build dealing with more complex code. Okay, so from there, keep continuing to be great people, and hopefully you're going through this tutorial early and you're going to finish the assignment early, because the rest of the semester is going to get busier and busier. But you're still going to be awesome no matter how busy semester is, no matter how you do, no matter what your grade is. It doesn't define your worth. If you think you're worthless, I fucking disagree with you, and I will swear publicly for that, and I will say you're always worth something.